This lecture is radical equations and rational exponents. Objective 1 is going to be solving radical equations. A radical equation is an equation in which the variable occurs in a square root, cube root, or any higher root. Solving radical equations containing nth root. Strategy contains 4 points. Point 1. It is necessary to arrange terms so that one of the radical is isolated to one side of the equation. For example, example 1, the radical equation has been solved for already. Had this problem was square root of 20 minus 8x, let's say minus x equal to 0, step 1 is going to be to solve for the radical equation, for the radical by itself. So for example 1, it was solved already. If you are finding an even root, check to be sure that the other side is at least 0. The reason is square root of a number can only be equal to a positive value. The lowest possible is square root of 0, which is 0. Notice that square root of 4 is never equal to negative 2, while negative 2 squared is equal to 4. So when you solve, make sure that the even roots are not equal to negative value. Point 2. Raise both sides of the equation to the nth power to eliminate the isolated nth root. Point 3. Solve the resulting equation. If this equation still contains radicals, repeat step 1 and 2. Finally, check all proposed solutions in the original equation. Notice that checking is required for this type of problems. The reason is extra solutions may be introduced when we raise both sides of the equations to an even power. Such solutions, which are not solutions of the original equation but are solutions of later on problem, are called extraneous solutions or extraneous roots. Let's solve this problem. As we mentioned already, this question the radical has been isolated already. So I'm going to step 2, which is power both sides by 2. Because this is considered second root, and when we square it, the square and the power by 2, the square root and the power by 2 is going to cancel each other. So we have 20 minus 8x power by 2 and x also power by 2 to balance the equation. Here you go, the square root and the 2 cancel out, and 20 minus 8x is going to be equal to x squared. This is a quadratic equation, and if we move the 20 and the 8x to the other side of the equation, we can see that more clearly. X squared plus 8x minus 20. There are 2 ways to solve this problem, probably more, but 2 major ways. One of them is by using the quadratic formula. And just a reminder, quadratic formula is x is equal to negative b plus or minus square root of b squared minus 4ac, all divided by 2a. In this case, a is the number up front of x squared, and 8 is the number of x, is the b value, and the negative 20 is the c. So we'll have a is equal to 1, b is equal to 8, and c is equal to negative 20, plugging in the formula and eventually find the two solutions. We can also use factoring, which is quite easy in this case. Pretty much in this lecture, most of the questions would be easy to be solved by factoring. And since 2 times 10 is 20 and 10 minus 2 is 8, x plus 10, x minus 2 is a good factorization of this problem. It is always recommended to check back through FOIL, through distribution. X times x is x squared, x times negative 2 is negative 2x, 10 times x is positive 10x, and 10 times negative 2 is negative 20. We see that this is 8x, so we were able to factor it correctly. At this point, there is something that's called zero product property, and based on this property, if we multiply two numbers and the result is 0, then either one of the number must be 0 or the other number is 0. So based on the zero product property, either x plus 10 is equal to 0 or x minus 2 is equal to 0. Or the solutions are eventually x is negative 10 and x is equal to 2. Now, I don't stop here because I was powering this equation by 2. That means I must check and make sure that the result is really solution of the radical problem. When x is equal to negative 10, the original problem was square root of 20 minus 8 times x equals to x. Notice that negative 8 times negative 10 is positive 80. 20 plus 80 is square root, that's 100, and this is not equal to negative 10. This means that 10 is going to be extraneous solution. We're going to check with x is equal to 2. Again, in the very first problem, 20 minus 8 times x, is that equal to x? And 8 times 2 is 16, 20 minus 16 is 4, which is equal to 2. So this solution checks, which means there is one solution and the solution is x is equal to 2. Next question is similar. Again, step 1 would be square both sides of this equation. I'm skipping step 1, which was solve for the radical, because the radical is solved for already. So square both sides. This way we eliminate the root. So that would be x plus 10. Now, x minus 2 squared is the same thing as x minus 2 multiplied by itself. Notice that x minus 2 squared is not equal to x squared minus 2 squared. In fact, it's equal to the entire x minus 2 times by itself. And we are going to distribute. X times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. And negative 2 times negative 2 is positive 4. So x plus 10 is equal to this quadratic equation. Now this is again a quadratic equation, so I'm gonna subtract x from both sides and subtract 10 from both sides to move all the terms to one side. X squared minus 5x minus 6. Again, I can use the quadratic formula. However, here it's not hard to factor out because minus 6 times negative 1 is negative 6, and negative 6 plus 1 is negative 5. So let's check again. X times x is x squared, x times 1 is x, negative 6 times x is negative 6x, and negative 6 times 1 is negative 6. We see that this is negative 5, so we worked correctly. I'm gonna remove that from my problem. Alright, again based on the zero product property, x minus 6 needs to be 0, or x plus 1 needs to be equal to 0, where I get two solutions, x is 6 or x is negative 1. Again, I must check. When x is equal to 6, I substitute in the very first equation x plus 10, which makes it 6 plus 10. Is it equal to 6 minus 2? I'm substituting right here. And that's square root of 16. Is it equal to 4? And that's a true statement because square root of 16 is 4, so that's a solution. Check with x is equal to negative 1. Again, in the very original problem, negative 1 plus 10. Is it equal to negative 1 minus 2? Or that's square root of 9. Is it equal to negative 3? And those are not equal, so it turns out that x minus 1 is extraneous solution. It is possible to have no extraneous solutions, zero extraneous solutions, or both solutions to be extraneous. In those examples that I have picked, one of the solutions is extraneous. Now in example 3, I have to follow step 1, and step 1 was solve for the radical. So I have to subtract 1 from both sides of this equation. And then follow the steps from above. And the steps from above were square both sides. When we square both sides, the 2 would cancel this root, and here we have a square. So 6x plus 1 to be equal to x minus 1 squared. Or x minus 1 squared again is x minus 1 times x minus 1. Now we're going to distribute. X times x is x squared. X times negative 1 is negative x. Negative 1 times x is negative x. Negative 1 times negative 1 is positive 1. 6x plus 1 is x squared minus 2x plus 1. Again, we're going to move all the terms to one side. And we end up having 0 is equal to x squared minus 8x. The 1 and the negative 1 cancel out. Now this problem is easier to factor because x is in common for those two terms. And if we factor the x, we end up having x times x minus 8. Again, based on zero product property, either x is 0 or x minus 8 is 0. So So get those two solutions, check. For x is equal to 0, in the very original problem we have square root of 6 times 0 plus 1 plus 1, is it equal to 0? That's square root of 1, so 1 plus 1 is actually equal to 2, and it's not equal to 0, so here we end up having extraneous solution. And then x is equal to 8. For x is equal to 8, that's square root of 6 times 8 plus 1 plus 1, is it equal to 8? 6 times 8 is 48, plus 1 is 49, so square root of 49 is 7. 7 plus 1 is equal to 8, so we end up having one solution, x is equal to 8. With the second objective, I'm going to continue with the next video.